हरिः कर्ता।
Now let's look into the next technique under data imputation, which is KNN. That's K Nearest Neighbors Imputation. So KNN imputation is a technique used to fill in missing values in a data set based on the values of its K nearest neighbors. Repeating again, KNN imputation is a technique used to fill in missing values in a data set based on the values of its K nearest neighbors. The basic idea is to identify the K most similar observations to the one with missing values, and then use the values of the nearest neighbors to estimate the missing values. Okay, so the main principle of K nearest neighbors imputation is uh, to identify K most similar observations to the one with missing values, and then use values of these nearest neighbors to estimate the missing values. That's it. So now let's have a step-by-step overview of the KNN imputation process. Step 1, as usual, identify the missing values in a data set. So that's what the first step. So identify the incomplete data. Start by identifying the variables or columns in your data set that have a missing values. So if you look into this data, there are three variables. There are three variables that need to be imputed using KNN imputation. The first column A has one missing value, the second column B has one missing value, and the third column C has one missing value. Okay. Now, then the step 2, once you have identified the incomplete data, then we can move on to the step 2. Step 2 is to split the data into complete and incomplete data sets. The complete data are the observations that do not have any missing values, while the incomplete data are the observations that have at least one missing value. Okay, again, the difference between a complete data and then incomplete data which are broken from the original data set is the complete data are the observations that do not have even a single missing value. Okay, whereas the incomplete data are the observations that should have at least one missing value. Then once you splitted the data into complete and incomplete data, we need to move on to the third step. That's choosing the K value. Step 3 is choosing the K value. So decide on the value of K which represents the number of nearest neighbors to consider. How many nearest neighbors you want to consider? So that value we have to decide. The choice of K depends on the characteristics of your data and the specific problem you're trying to solve. A smaller K value will result in a more local estimation, while a larger K value will result in a more global estimation. So let me put this down here so that you can have more clarity. So K nearest neighbor, K, let me put it as capital N, K nearest neighbors imputation. Okay, so now the point here is if K is small, if K is small, it leads to the local estimation. If K is large, it leads to the global estimation. Okay. Then once you have chosen the k value, now it's time to the move on to the step 4. That is, for each observation in the complete for each observation in the incomplete data, calculate the similarity or the distance between the observation and all the complete data observations. So this is typically done using a distance metric such as Euclidean distance or Manhattan distance or cosine similarity. So let me write down these ones. To calculate similarity, we use either Euclidean distance or Manhattan distance or cosine similarity. So the distance or similarity measure is used to determine the closeness of observations, how close they are. Then we will select the step 5, select k nearest neighbors, identify the k most similar observations, that is k nearest neighbors to each observation with missing values based on the calculated similarity or distance measures. These k nearest neighbors will be used to estimate the missing values. Then once step 5 is done, after identifying the k nearest neighbors, we need to estimate the missing values. For each observation with missing values, use the values of its k nearest neighbors to estimate the missing values. So this can be done by taking the average, median, or weighted average of the values of the k nearest neighbors. The choice of estimation method depends on the type of data and the specific problem. Then once estimation is done, now it's time to replace the missing values in the incomplete data with the estimated values obtained from the k nearest neighbors. Then it's all done. It's by now all setup is done. Now it's time to validate the imputed values. So validate the imputed values to ensure their accuracy and reliability. So this can be done by comparing the imputed values with the actual values if available. So conducting statistical analysis or using some validation techniques, you can validate your accuracy and reliability of imputed values. Then last step, that's complete data imputation. Once all the missing values in the incomplete data have been imputed, the data set is considered complete and can be used for further analysis or modeling. And this is what, and these are the values has been replaced. These values should be replaced. After 2 and 4, you will get 3.0 for the column A, and after 5 and between 7, you will get the 7.5, and for the column B, and for the column C, it is after 10 and 11, you will get 10.5. So that's what and that's how the k nearest neighbors imputation works. So now let's take one simple example, and then we will we'll wrap this k nearest neighbors. So we need to import pandas as pd, then import numpy as np, then from sklearn impute module import knn imputer. That's what the issue here. see impute and then import KNN imputers. That's it. KNN imputer has been imported. Now let's cross check our data set, and this is our data set where we have the null values or values are missing for column A, column B, column C. So let's take this code exactly from here and paste it here. Now the next step, immediate next step, what is that? Splitting. So let's split the data. Let's split the data into complete and incomplete data. So complete data is equal to df drop NA as we have done before for the regression, and incomplete data is equals to df of and is null. If anything is null, then and dot any method, use any method, and access is 1. So if you want to see the respective data's complete data, and this is what is our complete data, only one row, then let's check incomplete data. There are 3 rows. Still it's gonna give the values for us. Still it's gonna impute the values for us. Okay. So let's get back to our code. So second step is done. Now the next step, check if there are missing values in the data frame. So let's cross check once. Check if there are any missing values in the data frame. So if incomplete data dot empty, then print, incomplete dot empty, then print no missing values in the data frame. Just we are cross checking if there anything wrong. At this moment it was executed. Else now choose the K value. Okay, if there are no missing values, then incomplete data doesn't have missing value, then there is no point of going for that. That's the reason. So then I'll go for the K is equals to 3 in this case. Okay, this is what my so incomplete data clearly has missing values, so that's the reason it will choose the K value. So with this we have come to step 3. Okay, step 3 has been executed. Next, let's move on in the same indentation block. In the same block, this is obviously block 1. So let's perform KNN imputation. Let's perform KNN imputation. So imputer is equal to KNN imputer, and I'm gonna go for the n nearest neighbors, and the K value is 3, the variable name I'm giving, and imputed values is equal to imputer dot fit transform, and which one? Respective data, that is incomplete data. So we want to fit and transform incomplete data with the KNN imputer method. So that's what. Now let's cross check the values. Let's execute and see what is imputed values for us, and these are the imputed values. Now so KNN imputation is done. Now it's time to replace the missing values in the original data frame. Let's get back to our slide and see here. So we came to the step 7, that is replacing it. Okay, let's replace. No, but before that, we have to make this imputed values as a data frame. Okay, let's create a data frame from the imputed values. So imputed df is equal to pd.dataframe and respective values, imputed values, and then columns. Let me give the column value here. So columns is equal to incomplete, sorry, incomplete data dot columns. Let's okay, there is some issue here. Let me check. Data frame object has no, okay, no issue. Let me cross check. Yeah, yep, done. So now let's call this imputed df and check what's happened. So what we got so far? Yes, this is what is your imputed df. Imputed df. So we got the imputed df. The values has been filled up. So 2, there is a null between 2 and 4. The value has taken as 3, and there is a null here, and the value is 7.5, and there is a null here, the value is 10.5. This is what is our imputed df. That's it. So the imputation is done so far. So now what else left for us is we need to concatenate this so we have to replace these missing values in the original data frame. That's it. This is imputed data frame. So we need to replace the missing values in the original data frame. So df of incomplete data and columns is equal to imputed df. Directly replace that. Okay, there is incomplete. Okay, same issue. The issue is coming because of tab. Okay, now it's no issue at all. So now let's print data frame after KNN imputation, and print the df, and here is your response. This is original data frame, and then data frame after KNN imputation. 2 and 4, the values 3, 5, 7 and 8, the values 7.5, and 9, 10, 11, and then here it's 10.5. That's it. This is our KNN imputation. So let me look back and let me explain this one more time, just as a wrapper. So in this example, we first check if there are any missing values in the data frame using df dot is null method and any. Okay, if there are missing values, we then perform KNN imputation using the KNN imputer class from the scikit-learn library. We specify the number of neighbors k, that's number of neighbors k value to consider as 3 in this example. So finally, we replace the missing values in the original data frame with the imputed values. Okay, that's it. This is our KNN imputation. So it's important to know that KNN imputation has its assumptions and limitations. For example, it assumes that similar observations have similar values which may not always be true. So additionally, the choice of K and the distance or similarity metric can affect the imputation results. Therefore, it's important to thoroughly understand the characteristic of your data and the assumptions and limitations of KNN imputation before you blindly using it in your analysis.